Assalamualaikum warahmatullahi wabarakatuh, and a very good day to my lecturer, Sir Ahmad Anis. So my name is Anuarul Irfan bin Muhammad Sofian, Matric number 288181. So today I'm going to present about my final project for subject SKIH 3113 Sensor Based System, which has the title of Intelligent Environmental Monitoring System with WhatsApp Alerts. Okay, so the objective for this project, as the title imply, which is Intelligent Environmental System Monitoring, um, our objectives will be to monitor the environmental parameters such as measurement of the temperature, humidity, and CO level, which is carbon monoxide, using appropriate sensor. Also, we also wanted to apply the real-time data transmission where the sensor data can be sent to a remote server for storage and analysis. And we also have an alert system where we can send WhatsApp alerts when specified threshold of the sensors are exceed. And of course, after we have the real data transmission, we also need to have an interface where user interface which is can provide a web interface to display real-time data sensor. Okay, so moving on to the architecture model. As you can see from this below diagram is my project architecture model where we use Arduino with sensor, specifically shown that the HT22 and MQ7 for the reading of temperature and humidity, and of course the MQ7 reading the carbon monoxide. So with this Arduino sensor, we also have phpMyAdmin, which will be as our database and also the user interface, and we have also a class named callMeBot WhatsApp API. So how this architecture model works is that the Arduino with sensor, especially with the central hub, which is the ESP8266, it will send the reading to the Wi-Fi network through HTTP post to the phpMyAdmin, where the reading of the sensor will be retrieved and stored in a database. So some of the data that we save is of course the ID, the sensor that we use, location where user can set up which location they are at the moment, and also the value of the temperature, humidity, and CO level, and of course the time step of each reading of the sensor. And after the data was sent through to the Wi-Fi network to the PHP database, we also send the data through the PHP backend server to the user interface, where this user interface is a web page hosted on the localhost server to display the real-time sensor data. So this user interface works as a dashboard for displaying the data retrieved from the database. Also, there's some coding that can be done to gain some insight on the reading of the data and some data analysis in the user interface. So other than that, also the Arduino sensor send the data through an API key, which is the alert message to the callMeBot WhatsApp API. So it is a hard-coded where if some of the reading exceed some certain threshold, meaning some dangerous alert or dangerous reading, this ESP8266 will send a HTTP post request to the callMeBot server, and depending on the condition, the system will construct an appropriate alert message about to the WhatsApp number that been saved. Okay, so the hardware components that we use for this project is of course our central hub, which is the ESP8266 microcontroller. It is a low-cost Wi-Fi microchip with full TCP and IP stack and microcontroller capability. It is highly integrated with an inbuilt TCP or IP protocol stack, making it a deal for IoT application. And also, it is data from the sensor, processes it, and send it to the web server. It also manages Wi-Fi connectivity and handle communication with the WhatsApp API to send alerts. So other than that, of course, we're going to use the DHT sensor, which is a digital sensor used for sensing temperature and humidity. It offers a high reliability and long-term stability, and it also measures the temperature in Celsius and humidity in percentage. And after that, we also use the MQ7 sensor, where MQ7 is an analog sensor designed to detect carbon monoxide CO levels. It has a high sensitivity and fast response time, but it's measured the concentration of carbon monoxide in the air. So how does this thing work is that the ESP8266 read the analog values from the MQ7 sensor, and then it will convert them to digital value and send the data to the cloud database. Okay, so this is the design in FreakSync, where as you can see here, we are connected some of the wire from the sensor to the ESP8266. So for me, we can see that the ESP8266 ground will be connected to the ground of MQ7 and the DHT22 pin. And also we're also going to use VIN, which supply of 5 volts power. It is specifically very good for the use of the DHT22 and the MQ7, where the manufacturer said that 5 volt of power can bring the most optimum reading. So the VIN of ACT2666 is connected to the pin of MQ7 VCC and DHT22 VCC. And also for the data, which is D5, the DHT22 pin of the DAT, which contain an output to send data to the D5. And last but not least, the ESP8266 analog pin also connected to the MQ7 analog pin instead of data, because this manufacturer designed the MQ7 to read it from the analog value. Okay, so for the data flow of this project, where it will be start first, where we start up all the ESP8266 with the sensor by ESP8266 connected to the sensor and connected to the laptop for the main power supply. And after that, the ESP will connecting to the Wi-Fi. Simultaneously, the HT22 and MQ7 reading start. So after it successfully connected to the Wi-Fi, it will send the temperature, humidity, and CO level values to the web server database for every 10 seconds delay. So the database that we're going to use is a phpMyAdmin. So the data stored in the database MySQL phpMyAdmin, and after that, the data stored in the database will be fetched for the web's interface. So after that, in the web interface, there will be some calculation and display for the mean, max, and average and all reading of the data that been stored in the database. And following that, we have a condition where if that some reading exceeds certain threshold, it will be the ESP8266 will set a HTTP request to the CallMePort API, where it alert messages delivered to the specific phone number. So after that, the reading will just continuously enter the database, and the user can see the data until the user can stop or end the system, so that after that it will be close the reading of the DHT22 and the MQ7. Okay, so for the data insight, where we set some certain condition, when if the reading of the sensor reach some certain value or some certain specific rules, we also calculate some data analysis to show that what does it indicate. So as you can see, this is all the rules for the temperature, humidity, and CO level insights. So as you can see, one of his example where if the average reading of the temperature is higher than 25 and the max reading will be higher than 30 Celsius, it will indicate the high temperatures and potential heat wave conditions detected. Same as humidity insight, also have if the average reading is greater than 70%, it also indicate some high humidity levels and possibly humid weather. So all of these data insight, where the rules are specifically being made by ourselves, where we tally it with the internet specification about the temperature and humidity CO level, which we can hard code it to the sensor, so that in the web interface, after collecting all the reading of the data from the database, this insight can be generated to indicate what is the data mean about, so that user can understand it better of their environmental monitoring system. Okay, so moving on to our web-based dashboard, where we use PHP as our back end, and also some of the database that stored the data, which is also PHP myadmin. So based on this web-based dashboard, as you can see here, is the reading of the temperature, humidity, and CO levels, based on their Celsius percentage and also in ppm. So here, as you can see from this diagram, it is the graph, and beside here will be the summary of reading of their min max average and also their insight, and also there's some gauge to see the level of the current reading, and also some of the latest 20 reading, which user can set it up by themselves by filtering it, and also the table that show the data that entered through the database and show it to the web-based dashboard. Okay, so to further in what is the web-based dashboard functionality is, it displays real-time sensor data such as the temperature, humidity, and CO levels, so that ensuring user have immediate access to the current environmental conditions, where it fetch the data from the database, where the database also fetch the data that been sent through the Arduino, which is ESP8266 microcontroller. So the dashboard also process this data to generate insightful interpretations, such as identifying hot or cold temperature, assessing humidity levels, like for dry or humid conditions, and evaluating CO level concentration for CO level indications. Also, it provides graphical representations, illustrates trends over time. So it helps to aiding in the identification of temperature fluctuation, humidity variation, and changes in CO level through accessible line charts. So there's also a review section where it presents the recent data entries in a table or list format. So providing a historical perspective that allows user to track changes and detect anomalies over specific periods of time, with options to filter and access the latest reading efficiently. And lastly will be the filter option, where user can filter as how many latest reading can be fetched, which will be shown to the review section and graphs. So for the insight levels, of course, insights will be gained from the data analysis through the PHP scripts, where the reading of the all of the data will be calculated using min max average, and also the insights will be shown in the slide before, where the threshold level value have been defined. And also, last but not least, this project also include the alert messages to user WhatsApp phone. So how does this work is where an alert messages will be sent to the user WhatsApp phone, provides a descriptive notification regarding the significant environmental condition or system event. So the alert message serves to ensure timely awareness and enables user to take necessary action in response to the observed environmental condition. So in this project, the predefined threshold are like extreme condition, where if the temperature exceeds 30 degrees Celsius, and also the high humidity levels above 70%, or the CO concentration exceeding 50 ppm, or combine of all three conditions. So if the sensor reads this type of exceed this type of threshold, so how does this work is where the ESP8266 will send a HTTP post request to the CallMeBot WhatsApp API. So this CallMeBot WhatsApp API receive the message from the HTTP request, and the bot specifically that being made for the API will be send messages to the user phone number that been set in the Arduino IDE code. So as you can see here from the diagram, if the certain level were met, the ESP weather station 2, which is the WhatsApp bot, will send the some alert messages to what happening to their environmental conditions. So how this works is that it will be sending this type of messages until the reading did not reach the threshold. So every time the reading exceeds the threshold, it will send this messages of alert for every seconds it will receive the HTTP request from the ESP8266. Okay, so to show the result of my finding, or to show a demonstration for this project, as you can see here, this is the sensor and my setup. I'm using MQ7 and the HT22 connecting to the ESP8266. And how it will be demo is that, first thing first, I'm going to show you this is the database from my previous reading for the testing. So as you can see here, this is all the data that been sent from the sensor through the ESP and send it to the database using HTTP requests. And from this data, this data will be sent it to the interface or the web-based dashboard. So here is the web-based dashboard. As you can see, here is the graph from the DHT22 and the humidity, CO, reading level and summary of reading, and the table of the latest reading that you can fetch. So all of this data were fetched from the database, and like being stated in the previous slide, where there's some calculation or data analysis that being done. So here we can see the minimum, max and average for all the reading of the sensor and some insight that we can get. So to show you how this thing to demonstrate you how this thing works from the start. So first I'll just truncate this table and I'll show it to you how the data will be sent from the ESP through Arduino IDE and sent to the database. So you're going to just clear it, the data in the table. So the table name is sensor data. Sensor data. Then after that we truncate it. Okay. Okay, so what truncate do was it clears the sensor data table, so that just to show you all how we get the reading. So after the database has been cleared, of course there will be no data available for the web interface to show. So now I'm going to connect my microcontroller with the sensor to the Arduino IDE. So first we're going to open the Arduino IDE. So here, as I said, it's not connected, and I'm going to connect it now. So yeah, the Arduino IDE is being connected to the laptop. So see, it still didn't connect it. It is because the Wi-Fi that been connected is not the same as the network credential being defined in the IDE. So we have to make sure that the Wi-Fi is the same. So I'm going to try to connect it to the Wi-Fi with the same network credential that being defined here. Okay, here is the same name, which is Trailblazer. This is the network credentials that been defined. So we have to connect to this Wi-Fi so that the ESP8266 can connect to the same network credentials, so that it can send or post the data to the server name of the DHT project ESP post data.php. Okay, so now it has been connected, so hopefully there's a message show that it will be connected in the serial monitor. Wait a second. Okay, so after we compile the code and send it to the ESP, so hopefully that the later on the ESP will be connected to the network credentials. So here is the prompt. Okay, let me refresh the serial monitor. So you see you can it's trying to connect to the Wi-Fi. Okay, so the network credential is the same, and here as you can see is the HTTP request data where the sensor, the HT22 and the location is reset to my room, and the value 1 which will be the value 1 will be the temperature, and the value 2 will be the humidity reading, and last but not least the value 3 will be the value of this carbon monoxide. So HTTP response code 200 means the data is successfully sent to the database, while as you can see here there must be some error in sending the message, mean that if the HTTP response codes showing -1 means that the data is not successfully entered the database. So we can see here there are some many response code of 200 or 208, so means that there are being a lot of data being sent to the database and will be updated. So we just refresh this PHP My Admin page, and yeah, so as you can see here, this is the reading that we got from the sensor through the ESP8266 through HTTP post to the database. And after the data already being stored in the database, of course this web-based dashboard will also be updated as it fetch the data from the database. So here, this is the new reading that we get from the ESP that we activated just now, the temperature, the humidity, the CO level, and the summary of readings. And here is the gauge that we can read. This is the current reading of the sensor, and also this is the temperature and humidity and CO reading of the latest 20 reading, because we set it to 20. We can also set it to 5 if you want to see what the latest reading of the most latest 5. So here, see here it changed, it only show 5 latest reading, so that it's easier for the user to see or to gain more insights on what they wanted to collect data from. So if we can just select it all, just set to 100 if you want to see it all. So here for only now we have only 14 latest reading, so this is all what it shows. So this is for the dashboard and the DHT. So next I'm going to show you about the WhatsApp notification, where I use to call the bot for some requests if you reach some certain threshold. So for like in a real life situation where if the temperature of humidity or concentration is high, of course we have something that needs to be alert to the user so that the user may know and take immediate actions. So for this example here, just say I'm going to I just set the temperature if it's higher than 10, just for an example. It will give a message to the WhatsApp which send a message of high temperature and potential conditions detected. So how does it send is that it send a HTTP request to using the API key of the Call Me Boss WhatsApp, and also you have to include the number of your WhatsApp according to your country. So after that, after the condition is met, where if the temperature is more than 10, the high temperature and potential heat wave condition detected message will be sent. So as you can see here, our reading is of course, let's set it from here. Okay, so you can see our reading is of course the temperature is higher than 10. So as you can hear, so I'm going to show you my WhatsApp. Yep. So the message has been sent by the WhatsApp bot to me about the reading. Okay, so I'll just show it better in the base WhatsApp. Okay, so as you can see here, the bot will just send the message after it detected. It will alert the user continuously after the threshold has been dealt with. So just for example, set to 10 and of course the reading is higher than 10. So this bot will just alert the user continuously until the user did something to change the temperature for it to not reach the threshold. So like in real life situation, it is better just to set it to 30. So just an example to set it to 10 so that to show you that the notification has worked. So I guess that's all from me. Thank you very much.